So next we take a quick look at the handling of the mouse. To start off with, again, we check to see if the ball is moving. Now, if the ball is still, we handle a drag operation. If the mouse button is clicked, the first mouse button, proceed with these commands. The shot height is set to its value plus the movement of the mouse on the y-axis. The first calculation is to multiply the movement by 10% or 0.1, negate so that it becomes a negative value, and add that to the shot height. So as the mouse moves down, the value goes higher. However, the further up you move, the value goes lower. So now we need to reverse that, so that as it goes up, the value goes higher. As it goes down, the value goes down. And the range that we want is between 0 to 100. So the clamp command will clamp that range of that adjustment and keep the height of the shot between 0 and 100. Now in this loop, in this drag loop, I want to have it wait 50 milliseconds. I don't want it to do too many calculations per second. We need to display the state of the drag, the shot height. So we use the text commands, the print command, to display the power of the height of the shot. And we do a little temporary progress bar. I could have used the box command, but I just used text, something nice and quick. So now that completes the drag operation. If here the second mouse button, now we're counting from 1, 2 and 4, the third mouse button would be a value of 4, because this is a flag command, this is a flag variable, so it counts from 1, 2, 4, 8, 16, multiples of 2. However, in this iteration we're only dealing with the first and second mouse button. We're not really going to do anything with the game if the middle mouse button is clicked. So now, if the second button is down, adjust the shot direction as the mouse moves left and right, and adjust the view height if the mouse moves up and down. Yeah, so if the left mouse drag adjusts the shot height, right mouse drag adjusts the view height. Again, we clamp it between 0 and 100, and with the shot direction we use the wrap value command to wrap the result between 0 and 360. So if the value goes below 0, loop back to 360. If it goes above 360, loop back to 0. Now, if the ball is moving, if the ball is not still, then proceed to this section of code. If the user right-click drags on the x-axis, adjust the direction of the view, not the ball. As the ball is moving, it goes in its own direction. However, you can look around by dragging with the second mouse button held down, and it will adjust the direction and height of the camera view. Finally, with all views, as you scroll with the mouse wheel up and down, you zoom. So therefore, we use the mouse zoom or the mouse movement on the z-axis to adjust the zoom. I'm only interested in whether it's moving up or down, which is why I've clamped the value to -1 from -1 to 1. So I don't want anything higher or lower than that. Tends to be pretty high, like hundreds or 1,000, depending what mouse you use. In this case, I want it to be either 0, -1 or 1, and then multiply that by 20 and add that to the view distance, whilst clamping the distance between what should be 4 and 100, not 104. Let's change that around, and that pretty much concludes the handle mouse function. So next we look at the handle velocity function. The first thing I want is to work out, obviously, the velocity, and we do that by working out the distance between the old ball position and the new ball position. Now, it's quite a common procedure to calculate the distance using the square root formula. So we can calculate the distance between the old and the new position and save it into the velocity. Now, in the level state, we assume the ball is moving by default, so we just clear the level state variable, which is the 5th bit of the level state double integer, and at this stage we store the new position as the old because we've done what we needed to do with the old position variable. Here we need to work out the velocity against the threshold of where we want to bring the ball to a standstill. Now, if the ball's velocity is below 0.04 or above minus 0.04, then the ball needs to stop. Yeah, anything that's moving within that range I will consider to be motionless, and I'll force the ball still. This is done by first checking how many times this figures out that the ball is in no motion. So every time the ball is moving extremely slowly, we count. We add 1 to this variable here, ball still loop count. Every time the ball is still, add 1 to this variable. Once it reaches 30, then we force the ball still. However, if the ball is only temporarily moving at this velocity and perhaps rolling downhill or moving up and then being affected by gravity and moving down in a transitional state, then no need to stop the ball. Let it continue moving. However, if it continues to stay still for a long period of time, set the linear velocity to 0, which causes the ball to stop moving, and set the angular velocity to 0, which will stop the ball from rolling. And if this is the 30th time the ball is seen as still, we set the shot direction to the current view direction. Now remember, the player can adjust the view direction as the ball moves, but once the ball comes to a standstill, I want the new shot direction to be that view direction. And then we increase the ball still count so that it doesn't redo this again on the next loop. However, if the ball does increase in velocity, we set the ball still loop count to 0 again. And that concludes the velocity and pretty much how the structure of the mini golf game looks in code. Next, we'll have a look at how the golf courses are created in 3D World Studio.